Hello students, welcome back to TutorHub, your e-classroom on YouTube. So today we'll discuss about the six trigonometric ratios and we'll have a step-by-step discussion about this particular topic, and hopefully you'll be able to master this topic. And for sure you've watched my previous video on this topic on the six trigonometric ratios, but hopefully through this discussion today you'll be able to gain more insights and more mastery about the six trigonometric ratios. But before we proceed, please don't forget to subscribe to my channel, like this video, and leave a comment on the comment section down below. Again, subscribe, like, comment, and share with your friends so that more people will be able to learn about math, chemistry, and other topics that we'll be exploring within this channel. All right. So without further ado, let us recall the six trigonometric ratios. But we have these three, which I would like to highlight first, which we call the primary trigonometric ratios. These are your sine, cosine, and tangent. So if you recall, sine is represented by the equation sine equals opposite over hypotenuse, or we simplify this as opposite over hypotenuse. That's why sine is usually represented as so. Then cosine is adjacent over hypotenuse. That's why cosine is usually represented as ka. And tangent is opposite over adjacent, or O over A. That's why tangent is usually represented as TOA. Therefore, for you to easily remember the six trigonometric ratios, we usually call these three primary ratios as SO, Ka, TOA to represent the formula or equations on how these three trigonometric ratios are solved. So that way you can easily remember and easily solve for the values of the opposite, the hypotenuse, or adjacent sides of the triangle using the trigonometric ratios that we will be discussing. So that's again so, opposite over hypotenuse, sine equals opposite over hypotenuse, ka, cosine equals adjacent over hypotenuse, and TOA, tangent equals opposite over the adjacent. Alright? So I hope you'll easily remember so, ka, TOA. Okay? The other three trigonometric ratios are the inverse of the first three. So cosecant is the inverse of sine, wherein cosecant is hypotenuse over the opposite side. Secant is the inverse of your cosine function, which is hypotenuse over the adjacent side. And cotangent is the inverse of tangent, which is adjacent over the opposite side. Okay? So you may be able to think about a mnemonic device for all this, right? So cosecant is hypotenuse over opposite side, secant hypotenuse over adjacent, and then cotangent adjacent over opposite. Okay? Now, if we take this example, for us to illustrate the six trigonometric ratios, we're given the two legs of a triangle. We know where the right angle is, and the angle alpha is being highlighted here, and we do not know the length of this leg opposite to angle alpha. So what do you think should we do first? Of course, because we have the length of two sides, and we do not know the length of one side of a triangle, then we will use the Pythagorean theorem to solve for the length of the third side, or the leg, or the other leg of the triangle. So using the Pythagorean theorem, we have c squared equals a squared plus b squared, and c corresponds to the hypotenuse, which is 15. So that would be 15, side A is 12, and B is what we are looking for, right? Okay. Do you follow, class? Are you still with me? Very good. So we need to simplify this equation. So using your calculators, 15 squared is 225, 12 squared is 144, and we have b squared, which is our unknown. Then we manipulate the equation. We transpose 144 to the other side to get b squared. We get 81 equals b squared, and because it is squared, we need to get the square root of both sides to get b, and b equals 9. Okay, so 9 is the length of side B. Okay, now that we have the length of side B, we can easily calculate for the 6 trigonometric ratios for the angle alpha. So with respect to angle alpha, this side 9, the leg with the length of 9 is its opposite side. The leg with the length of 12 is its adjacent side, and 15 is the longest side, and that would be the hypotenuse. Okay, so now you can solve for the 6 trigonometric ratios using these values. Starting with sine theta. Sine is so opposite over hypotenuse, 9 over 15. That would be 9 over 15. Simplify that, 3 over 5. Very good. Okay, were you able to get that? Next, let's go to cosecant theta. That's hypotenuse over opposite side. What's the hypotenuse? 15, very good. Opposite side, 9, very good. So that's 15 over 9. Simplify, 5 over 3. Very good. So far, so good. Okay, so it's simply being able to know the formulas, understanding the length of the sides and the angles that you're focusing on, labeling the sides as the adjacent, opposite, or hypotenuse of the angle that you are considering, and substituting the corresponding length of the sides of the triangle to the formula of the trigonometric ratio. So that's how easy it is. Cosine alpha, again, cosine is adjacent over hypotenuse. What's the length of the adjacent side? Very good, 12. Hypotenuse is 15. So that's 12 over 15. Simplify this further. That's 4 over 5. Okay, very good. Cosecant alpha is equal to hypotenuse over adjacent. Where's hypotenuse? 15. Adjacent is 12. So that's 15 over 12. Simplify further. That's 5 over 4. Very good. So tangent alpha, again, opposite is 9, adjacent is 12, hypotenuse is 15. So opposite over adjacent, 9 over 12. Then simplify further, that's 3 over 4. Okay? Cotangent is adjacent over opposite, adjacent 12, opposite 9, that's 12 over 9. Simplify further, that's 4 over 3. Is it all clear, class? Very good. So I hope you're able to follow how to solve the values of the 6 trigonometric ratios given the length of the sides and knowing which angle you are focusing on for the particular triangle that you're considering. Okay? Now let's have another example. So you have, again, two sides here, 24 and 7. You don't know the length of the hypotenuse. So what do we do first to solve the 6 trigonometric ratios for this triangle? Okay, the clock is ticking. What do we need to do? Very good. So first, we need to use the Pythagorean theorem to solve the length of the hypotenuse. So that would be c squared, and a would be 24, b would be 7. Solving that, using your calculators, 24 squared is 576, 7 squared is 49. Add that, 625. Get the square root because this is squared. So get the square root of both sides. C now becomes 25. So the length of the hypotenuse is actually 25. Now that we have the length of the three sides of the triangle and we have angle alpha here, we will need to identify the corresponding sides with respect to angle alpha. So with respect to angle alpha, 25 is the hypotenuse, 7 is the adjacent side, and 24 is the, very good, opposite side. Okay? Now, getting sine alpha, sine is opposite over hypotenuse, opposite over hypotenuse. That's 24 over 5. Can we simplify this further? No more, not anymore. So that would be the final answer. Okay? Cosecant alpha is hypotenuse 25 over the opposite side over 24. That's 25 over 24. Okay? Next, cosine alpha. Cosine alpha is adjacent 7 over hypotenuse 25. So that's 7 over 25. That's already simplified. Secant alpha is hypotenuse 25 over adjacent. That's 7. So that's 25 over 7. And for tangent alpha, again, this is alpha. This is the opposite side. This is the adjacent side. This is the hypotenuse. So tangent alpha is opposite. 24 over adjacent 7. 24 over 7 cannot be simplified further. So that would be our final answer. Cotangent alpha is adjacent, which is 7 over over opposite side 24. So that's 7 over 24. So that cannot be simplified further. That would be our final answer as well. So I hope you learned something today, students. That's our review on how to solve the 6 trigonometric ratios using the formulas that we had. So I hope you're able to learn and master the concepts. Check out my previous video about the 6 trigonometric ratios and come back to that to master the topic again, to master the topic more. And don't forget to subscribe to the channel. Please like the video, share with your friends so that they can also learn about this topic, and leave a comment about what you would like to learn in the next video. So again, thank you everyone for joining me, and thank you for watching TUTORhub, your e-classroom on YouTube. Happy learning, everyone. Bye!